Devi or Sanjano. So today we are going to do the experiment Malus Law. In Malus Law, to determine the absorption coefficient of a transparent material glass light to verify Malus Law. So first of all, we have to determine the transmission coefficient of a glass light, for which we have to measure the light will pass through the glass slide and it will going to absorb in the glass light. So we have to measure the thickness of the glass slide. First of all, T thickness. As you can see here in the table, we have to measure the thickness of the glass slide and we have to note down here. Then on that thickness, we have to see intensity on the photo detector. So first of all, total we have 6 number of glass slides. Here you can see one of glass slide is here. So we will show you how to measure the thickness of the glass slide. So first of all, take the glass slide. First of all, let me tell you about the least count. So as you can see here, this is our vernier scale.
No, screw
Sorry,
gauge.
screw gauge. Sorry for that mistake. कभी कभी हो जाता है.
So the minimum reading of main scale is
It's
1 millimeter, and the total number of circle divisions are 100. So 1 divided by 100 means 0.01 mm is the least count.
Yes, 0.01 mm is the least count. Okay, so how we will measure? We will take our glass and we will uh, put it here, and not by this, it will break the glass. Okay, slowly by this. One, two, three, four. Four count. You measure the four tick of this, and after that, you will measure here. So as I can see here, it is showing approximately 1.26. Okay, so it's 1 millimeter on the
So we
main
have to
scale.
coinciding it with this central line.
Central line, yes, these lines we have to coincide with these lines. So as you can see here, it's 20, then it's 30. So it's meeting in between of 20 and 30, and I have observed clearly. So it is around 26 in between of 20 30. It is matching
27.
with zero line with where is the pen? I let me show you. Okay, so you can see here, it's 20 and it's 30, and this zero line is matching with, wow, this zero line is matching with, you can see here,
27.
approximately 27. Okay, 27, then it's 1.27. Okay, so it's one. So let me show how I have calculated. uh, Main scale reading is 1 mm plus least count multiplied by the least count vernier reading. Okay, so 1 mm plus least count, as I have told you, 1 main scale divided by total number of vernier scale. So 1 divided by total number of vernier scale on this round surface is 100. So least count is 0.01. So least count is 0.01 multiplied by vernier scale. We have calculated right now just 26. So it will be 1.26 millimeter. Our first reading. Similarly, we will calculate it for the other glass materials, like this, like this. And let me tell you, approximately all the ratings are approximately same: 1.25, 1.37, 1.17, 1.27, 1.29, 1.2. So in case if you forgot the rating, just directly write down from your side. It's okay, it will be fine.
And in the main table, we have to measure. We have to write down the total thickness that we are putting. For example, for one slide, the thickness is 1.25. For two slides, we have to add up consequently, and for six slides, we'll get a total thickness of 7.61.
Like here, let me show you. Like here we have added this, added plus this give our main reading this plus this give our main reading this plus this give our main reading this. Like this you have to add it, and we have added until for 7 plates. Like here 3 plates, so it
Six
will come
plates.
approximately 3 point something. So as you can see, it's 3.79 approximately.
So this is the Malus Law experimental setup. Here we have our laser diode, which is mounted on the breadboard.
This is mounted on the breadboard, and this will be the place where we will insert our glass slides. And this is photo detector. I will not let you speak. And this is our the detector output measuring unit, where we will see the output.
These two knobs are for adjusting the photo detector linearly and horizontally.
And what is the work of this?
This one is polarizer and analyzer.
बाद में आएगा. This is the setup for which, by using this screw, we set the center here, the laser light of the center, we have to match it with this center, and it should be approximately 195 microampere, approximately that much will be enough.
Here we have two scales in the output, microampere and milliampere. So we have to measure in microamperes.
Okay, so first of
Now
all I'm going
turn
to
on.
turn on the circuit. Wow, as you can see here, the output is right now 195 microampere, so that's perfect for taking
So,
readings.
so this will be the I naught.
This will be
See
the I
here.
naught. Okay, now I will insert, as we have measured our glass plate 1.27. So I will insert this glass plate here, and you will observe the decrease in reading. So I'm tightening it, and make sure, first of all I will tighten it. I will show you that how you have to tighten it.
This glass slide mount has four screws
Four screws, so tight it with like this. Okay.
and
Then
it is rotatable. So we have to make sure that it is fixed on a fixed angle.
okay, so like this, as you can see here. Okay, turn it out. After insert, uh, tight it with these screws. So better, like one screw will be completely tight, and one screw make sure, like how I basically, the glass slide should be straight. You have to tie it in that manner, otherwise like the absorption coefficient will be different.
And try to this glass eye should be mounted in such a way that its reflection of laser light should fall on the laser light mount.
Yes, like this. Or you can measure the angle here, 81 degree. Make sure that it's 80 or 81 degree. You can match this angle again and again, so that it will be on the same direction. Okay. Now you can see the decrease in the reading. It's 176. Okay. Earlier it was 195. Now it's 176. I'm now I am considering it's a little bit thick, so it should be approximately 1.29 or 1.30. So again, I'm going to insert it here for my second reading. So for my second reading, I will take it out. I will take it a little bit low. I will enter these two plates. Then I will tight these two, and I will match the 81 degree exactly. So now
So as you can see again the current is decreased, and
approximately
we'll note
148.
these we'll note these values in a table like this.
You can see for 2 it's 145, and our reading is coming out approximately 148. Show here,
It's visible.
it's 147. So
Mhm.
it will decrease like this similarly. And I
So
can show you one more reading if you want, like third case, so that you get enough confidence in the exam. Thank me later. You can send me money you via Paytm or whatever you are feeling comfortable.
OLX,
The videos will be uploaded on OLX, so you can directly purchase from there. Not more than just.
those who are watching they have already purchased.
Yes, so congratulations, you got the videos. Yes, so as you can see here, it's 128 for 3 slides. So it's 133 for 3 slides. So like this,
So
it will
similarly,
decrease.
we will take for 6 slides. Now let's do the second part of the experiment to verify Malus law.
Good morning, मेरे नन्हे मुन्ने प्यारे बच्चों. So today we are going to do Malus law. As you can see, I naught is right now our 189. So I will insert one polaride, and it will decrease the value of I naught up to half. So it will decrease the value of half. Okay, but make sure wait. Okay, so good afternoon, everyone. So today we are going to do Malus law. Sorry for the inconvenience. So we have to first of all we have to take the reading here approximately in the range of zero point 0.5 to zero point 0.6 milliampere, not microampere, milliampere. Then after that, I will insert one polaride, so it will make decrease the intensity up to half. Up to half it will decrease, so from zero point 0.7 to point half. Now I will tight it, and make sure the reflection is inside the diode. Okay, so it's half approximately. Now turn it into the microampere. So in microampere it will be approximately 174. You can increase it for up to 180. uh, 180 or go to 190. 190 will be better. Now maximize it up to 190. Now insert second polaroid. Insert second polaroid and tight it. After tightening, maximize it with this, with the help of this, and maximizing it. So it will going. So maximum cases, as you can see, maximum condition is 70.
Maximum will be achieved by rotating this. चलो ठीक है.
Okay, let's start. Okay, for example, let me tell you what we have done till yet. I have on the power supply. We have set. So after inserting this polaroid, we have to rotate it to maximize it. So as you can see here, it is showing 0. So we will rotate it so that it will show the maximum value. So I'm rotating it. You can see the maximum value is now, it's 170 decreasing. It will going only, I'm rotating anti-clockwise and clockwise both. So it will going up to 176, not more than that. So 176 will be the maximum value. So I'm going to make it 176.
So at this position, we have to note down the angle that will correspond to 0 degree. This is the actually angle between polarizer and analyzer. So at 0 degree, we have to note down photo detector current. It should be maximum, then it will decrease from 0 to 90 degree. Do it fast.
Wait, it's not rotating. What is the maximum intensity is at 174.67. Okay, the maximum intensity is this right now. So we have to rotate it and set it at maximum. So there will be a position when when you rotate either clockwise or anti-clockwise, you will get a maximum value. So you have to fix your polaroid on that position to the maximum value after
And
inserting first
and at
polaroid.
this maximum position, it is the position when the angle between polarizer and analyzer is 0 degree.
0 degree. So the whole component electric
Now
field vector passes.
we can note down the 0 degree position.
Okay, so let me.
Hold this.
So as you can see here, zoom it. The 0 degree position is 300
To 10.
10 degree. So I will rotate it to 320, and then we will see the uh, change in the intensity. So I have rotated it to 320 degree, as you can see, approximately. So let's see the change in the intensity. So from 178 it decreased up to 177.
Hmm.
Well, actually we are using phone, that's why it's maybe a difference in the intensity. Now I'm rotating it again with a 10 degree. So after rotating it again to 10 degree, let's see the change in the intensity. You can see it's 167 around something. Similarly, the intensity will keep decreasing. Now I'm rotating it again 10 degree. So the intensity will decrease now again 154.
Similarly, we have to take up to 90 degree.
Okay, so wait, pause.
Hmm.
So like this we have to decrease, rotate, and it will decrease up to. So better, like we have chosen, let me show you the table. We have chosen the intensity 195, that's why it's coming approximately 79 after rotating
135.
up. In the table we have chosen 135, so it's coming 36. But today we have chosen 195, that's why after rotating 90 degree it's coming around 79. But do one thing, like Select the intensity 135.8 only,
Hmm.
or little bit less than that, so that your decreased value should come in the range of 20 to 30. That will be better. Okay, so that's all for today. Thank you so much.